Now can you hear me? Yeah. Now okay, no? Sorry, there was a issue. Can anyone send me message? Can you hear me clearly? Yes or no? Put in the chat. Okay, thank you. Thank you, Janindu. Thank you, Setma. Okay, okay, thank you, Dinul. Okay, as I told earlier, today we going to start our most important, very new lesson. This is courses. I hope you already completed last day tutorial structured part. You already completed. I hope. I'll send you answer script into the group. Then you can compare with this. If there are any mistake, you can correct. And if there are any unclear point, you can feel free to ask me. Okay. Then you can complete the measurement lesson. In measurement lesson, every measuring instrument, then every the parts of every measuring instrument, then there are functions, each part functions, how to work each measuring instrument, then what are the errors, zero errors, fractional errors, percentage errors, everything we have discussed in the measurement lesson with practicals, not only theory. We within the class we discussed several methods we used to identify each instrument. As you, I think the measurement lesson full, you got the idea about the what is the purpose of learning measurement lesson. Okay, measurement lesson actual, in measurement, only measurement lesson not coming more exam questions, actual things. But for our future lessons, the measurement knowledge is important. The measurement knowledge is important for our future lessons. Therefore that lesson very important. Not like that the forces of today we going to start our second lesson. Actually it's not the second lesson, but in our class we doing this as a second lesson because that is most important lesson in the syllabus. Okay, we, you already know we have 25 lessons. No? From this 25, the forces is the most important physics lesson. If you can't understand physics lesson, if you miss any part of the physics lesson, then don't think about other any physics lesson. That's the thing. Normally we have 8 physics lesson. The first one is measurement. After measurement we go our second physics lesson, actually forces. Our second physics lesson is forces. If you miss any part of this forces lesson, in this forces lesson I will explain. We have, that's a long lesson and this little bit bulk. I think you already have tubes. You can see the forces lesson tube is the most bulk lesson, most big lesson, big tube, bulk tube. But don't think it has, normally I think 30 to 32, 30 or 32 pages. No, yeah, it little bit large lesson, but it is not difficult. It is some part of the force lesson actually you have did in the O-level time also. O-level time also, force equilibrium, force the resultant force, force resolution, everything, some parts we discuss. But in this A-level level, now in our lesson, in our syllabus, we going to discuss further about further than O-level knowledge. If you know up to think a little bit in depth each topic, we going to discuss in depth of each topic, and we going to discuss different calculations of these each topics. Okay, then after that you can understand, we have to understand what are the applications of each what are the applications of each topic. As example, when we consider about movement of forces, I think you familiar movement of forces. Don't think, if you don't know, don't think we discussed everything under movement of forces. The movement of forces, there are many type of applications. As technologists, you not going to be a doctor or whatever. You will be a technologist. Therefore, we discussed everything required knowledge for a technologist with these topics, with this knowledge. Okay, therefore that is very interesting lesson, very interesting and very important lesson. As I told earlier, is there any part missing in this fourth lesson, the entire physics part is very difficult. This 8 lesson, all 8 lesson is okkomamaru. It is very difficult. It will be very difficult. Okay, therefore try to try to keep your attention 100% into the lesson. Then you can get maximum 100% idea about the each topic we discuss in the fourth lesson. Okay, fourth lesson not like measurement is very small lesson. Within 7 days we completed, but at least we can't get for this lesson we can't get more time, but we have to complete quickly. But we have to, each part we have to discuss in depth we have to discuss each part. As example, I will show you what are the parts we need to discuss. We're going to discuss in this fourth lesson. In this fourth lesson we're going to discuss about forces. We're going to discuss about the first part is, in the first part of the force lesson, we discuss the basic, what is the meaning of the force, basic of forces. Basic, that actually today lesson is basics of forces. Basics of forces. What is the meaning of force and what are the characteristics of forces? Okay, that we discussed in the first part. In the second part, we going to discuss about Newton's law. Actually, the Newton's law we discussed as second part, but the full 100% idea of the Newton's law you can get the at the end of the lesson. Again, we discuss Newton's law, then you can get the 100% idea. Okay, don't think there. But before we go to the advanced point, you have some small idea about Newton's law. That's why I explaining as second part. Okay, Newton's law. Newton's law is our second topic. After that, as our third topic, we have to cover about friction force. Yeah, you already know in O level time some part of friction force knowledge you have, I think. Am I correct? In O level science there is a lesson as friction force, no? Am I correct? In O level time there is a lesson called friction force. Yes, very good. Actually, I don't remember the syllabus. I think you should know. You should have in O level time. The O level syllabus I not much familiar. Setmal, I am it. Yeah. I remember. I did O level. How many years? Now my O level year is 2016. No, 2015. 50. My O level 2050. My A level 2080. 2080. Not like now in our time, A level. In our time, the exam timetable is it's regular. No any extension, no any changing. The 2015 December O level, 2018 August A level. No any now your in your exam also it will come to the normal range. Your O level, I think, what's the month your O level did? Which month you did the O level? Oh, March. Totally different, no? December 1, then 4 months late. 4 months late, no? 4 months late. Okay. This 4 months we have to cover. Then normally from 2020, when we come to 2027, your A level again come to the August. Now, 2026 students also A level exam will be held August month. Therefore, your exam definitely will be held in August. Okay, therefore you have to ready for August. Oh, now you already missing 4 months. 4 months because your normal the academic timetable, according to academic timetable, you have to participate for O level. You have to sit for O level December, but you sit March. No, 4 months late. 4 months late, but it's for all the students. Therefore, it's no more issue. ලොකු අවුලක් නැහැ. Okay, as we discussed about parts of the forces. Okay, first we discussed the basics of forces. Next we discussed about Newton's law. Third one is friction force. The fourth one is force resolution. The fourth one is force resolution. Force resolution. Don't think we discussed everything. Force resolution, I think you didn't have in the O level, no? You didn't have. Am I correct? Force resolution. Force resolution? No. Force resolution? No. Okay. Our fifth part is, next part is fifth one. Our next part is resultant force. I just writing topics we need to discuss in this lesson. If you don't know any topic, don't worry. If you know, you no need to come to the classes. If you don't know, that's okay. We can discuss. Okay, if you don't know now about micrometer or vernier caliper, it has a problem. Okay, it has a problem because we already discussed about measurement lesson. We already completed. If you have any doubt in measurement lesson, now you have a small problem. You have to cover how a method by recording or whatever method, you have to cover that. If you don't know any part, that's okay. We can discuss. Okay. Sixth part, resultant force. Our next part is movement of forces. Yeah, all are forces, no? All are forces, you can see. Basics of forces, Newton's law related to force resolution, forces. All are forces. Okay, different types of forces we discussed in this lesson. Okay. Movement of forces, are you discussed in the O level time? I've learned. Yes or no? You did, no? In O level time, you did the movement of some small part of movement of forces, but in this syllabus, in our syllabus, movement of forces we discuss in depth of movement of forces. Okay, therefore that part is very interesting. Keep attention. If you understood 10%, the basic 10%, if you understood, other 90% is simple. But if you miss any part, it will very hard. Okay, therefore very interesting lesson. Not like actually more than measurement. This after that measurement lesson actually like a theory lesson. No any more calculations. It's just a theory. Some zero errors, small calculations only. But in forces and other physics lesson, we have lot of calculations and very interesting calculations. Therefore, no more thing to remember. very easily we can discuss these lessons. But if you can't do more mathematics knowledge, if you don't have any mathematics knowledge, or if you have wait, I change my Wi-Fi. Okay, if you don't have any mathematics knowledge, think if at least if you have SOC pass for maths, SOC pass, you can do. If you want to go your targets without any problem, you can do any calculation in our syllabus. And applied physics calculations we not going to discuss. Okay, we're not going to discuss applied chemistry, applied physics calculations, but we discussed actual day-to-day life applications, and they are each as example movement of forces. We discuss their applications in our day-to-day life and in industrially day-to-day applications and calculations. And you can use calculator, you can use scientific calculator as well. Therefore, if you have science maths knowledge up to COS level, that much enough. If you have B, that's good. If you have A, that's perfect. Okay, you can do it very easy. But I need to tell you, if you have at least SOC pass for maths, you can do any all calculations of these lessons, physics lesson, knowing. Kabir, am I clear? My board and my sound clear? Is there any problem? Everything okay? Yeah, there was a connection issue. Oh, now okay, no? Good. Okay, no again connection problem. I think I have changed the Wi-Fi router. That's why the problem. Okay, now it's stable. Okay. Okay, no issue. Okay, our next part is movement of forces. Our final part is couple of forces. Our final part is couple of forces. Couple of forces also you did in the O level, no? Couple of forces. Couple of forces. Yes, no? Couple of forces you did in the O level, no? Can you send me example for couple of forces? Example for couple of forces. One is water tap, no? Water tap is one. Other? Steering wheel, very good, you know. Then easy. Then 8, the final one is force equilibrium. Force Force equilibrium. Okay, that's the, you can see everything we discussed about, every topic we discussed about forces. Every topic we discussed about forces. They are the topics we have to discuss on the force lesson. I think I given the summary of the force lesson. I giving a summary. Forget. I think all words, all topics are you familiar in O level type, but not only O level knowledge. We going to discuss little bit further discussion about this each topic. Further discussion about of each topic. Okay. Okay. Now we're going to start about the basics of forces. Basics of forces. Basics of forces. Okay. Now get your tute. Get your tute. Get your tute. Before that, I will explain. If you don't have tute, your tute pack is coming. Your new tute pack. Printed tutes already finished. Now I printed 50 tutes packs at the last month for your starting for your 2027 batch. Now 50 is missing. 50 tute packs is finished. Now the new 35 tute packs come for tomorrow. Coming tomorrow. Therefore, you can order. If you don't have tutes, please send me message into this number. WhatsApp message. My WhatsApp number you already know. Send me WhatsApp message into this number. If you don't have tutes, I can within Monday to Tuesday next week I can send you into your home. Tomorrow I can't. Day after tomorrow I can post. Within 2 days you can get your tute pack. Therefore, don't worry if you have tutes. Send me quickly WhatsApp message if you don't have tute. If you don't have tute. Other thing, if you ordered your tute pack, still I think 2 to 3 tute pack I couldn't send you. I couldn't still send because the printed tutes already finished. Therefore, tomorrow I can send. Day after tomorrow I can send. Don't worry if you didn't receive. I can within Monday, Tuesday you can get your first tute pack. Your first tute pack is include 3 lessons. 3 lessons tute. First tute pack include measurement, forces, this lesson tute. Then you have rotational motion lesson. Rotational motion, our third lesson. Rotational motion tute. Your third tute, first tute pack, you have 3 lessons. Measurement we already completed. Now today we start the forces lesson. After that we discussed the rotational motion lesson. Okay. Then when we complete the rotational motion lesson, you can get the into your home. You can receive your second tute pack. It also 3 tutes. Therefore, you only need to pay postal fee only 1 time per 6 months approximately. Therefore, only need to, I think it is 200 to 300 around value postal free only. You have to pay for into post office. It's only for 6 months, 1 time per 6 months. Therefore, it's no issue for you. Okay. Come to the lesson. Okay. Okay, before we going to discuss about advanced point, do you know what is the meaning of forces? What is the meaning of force? Not forces. What is the meaning of force? What's the meaning of force? Any idea? What's the meaning of force? What's the meaning of force? Balayak. What's the force? Any idea? Yeah, good. Others? Force is a physical. Very good, Fatih. Very good. Others? Others? Very good. Very good. You all are correct. The force is a physical quantity, or it is an external agent. Actually, force is a physical quantity. As we discussed in the measurement lesson, the force also a measurement. The whatever physical quantity. Then in the measurement lesson we discussed, when if there are any physical quantity, if we get any numerical value for any physical quantity, that is a measurement. Okay, samely the force also a physical quantity. The physical quantity, that's an external agent. An external agent external agent which can change the motion type. Remember that motion type of any object. These definitions you have to remember. Today we going to discuss about very basic of the forces, no? Therefore more advanced calculations today we will not meet, but the basic definitions, basic things you have to understand. As I told, if you go part by part, this force is very simple. If you do you know now, if you can ask from 2025 students, if you ask 10 to 2025 level student, what is the most difficult lesson in the syllabus? I think from 10, approximately more than 7 students, they will answer the force is the difficult lesson. Force is a difficult lesson because the reason they don't have covered at the beginning to end this lesson. My advice, if you follow this, if you keep attention at the beginning to end of the lesson, we going to start from the basic, then finally we go to the force equilibrium. If you keep attention, if you come to class continuous, if you follow our methods, if you follow our each calculation and tutorials, well, the force will be very easy lesson for you in the future, because no need to remember more things, only rational point you have to, if you understood, they will not again forget. Okay, not only in biology, like biology we can't understand these things, but only few definitions you have to remember. You have to remember the key words of the definitions. Okay, but you can ask from our 2025 students now. Our class, we have done perfect. Okay, we have done perfect each lessons. You can ask from our 2025 students. You know, 2020, I think you already know 2024 result. We are the first and only 2A passes got in the 2024 in our subject. Okay, therefore, if you now you can trust us. Okay, trust our program. You can trust because we have got 2A's. Any other class don't have, they have maximum C. You can find no, at least no B, but we have 2A's and 2B's. These are only my first batch. This only my, the 2024 is my first batch, first A level batch, because I did this class. I did this 2024 class, 2024 class at the final year in my university. Now I already graduated in University of Jawaharlal. I did this class at the final year or in my degree, but we have got this result from only 10 students in our class. Only 10. 4 students has A and B. I will plan, because I will schedule these students to speak you. They will advise you. The problem is they are in different. Now they are working. I will prepare a special meeting for you. They will advise you how to work to get A or B. That should be your target. If you work more than 2 years, if you work for this into target, your achievement, your final result should be this level. Otherwise, it is the time wasting. Otherwise, that's not value. Therefore, keep your target in the highest value, highest target. Then otherwise, your brain will automatically prepare for your target. Otherwise, if you work only to get C, your brain is prepared for this target. If you want, keep your targeting to get island first, no issue. Island first also in your exam. Island first also. Students like you working like you, he or she also learning this syllabus, these lessons. Okay, the same paper is come, same paper, same time. But yeah, you also can. Therefore, keep your target in highest range, highest level. Okay, then your brain is automatically prepare for work on that. Otherwise, if you don't have a proper target, very difficult to prepare your brain into work to work. Okay, I think you got. Okay, normally we don't go into, after we start lesson, only first day we is doing different things in the class. After we start the lesson, we not going to discuss anything. We only doing lesson. Okay. At the measurement lesson also, you already know, we at the first day only we discuss different things for your life. After start the lesson, we only discuss the lesson. That's our nature of our class. Okay. The force. What's a force? A force is an external agent. The force is an external agent which can change the motion type of any object. The force is an external agent which can change the spelling of. Which can change the motion type of any object. Yeah, if I got the meaning? No. Now it is very simple. The force is an external agent. External agent means, think this is a rod. Okay, this is a rod or whatever surface. This is a rod. Think that's a box on this surface. That's a box. That's the object. Okay, when I give push or pull, okay, push or pull, then that is the external agent, no? Push or pull, whatever external agent I given, whatever external agent I apply on this object, then we can change the motion type. Change the motion type is now at the beginning, before we before we apply this external force, before we understand, before we apply this external force, think the object is raised. Now this object is raised. Object is raised. Object is not moving. When we apply external force, think when we apply external force, when we increase, when we think, just simply understand, when we apply external force, external agent that we called as force, we can move this object. Then that external agent is the force. Then you can see the motion type is changing. Change the type of motion type of the object. Change the motion type of any object. Change the motion type means, when we consider about the motion type, there are four main motion types. The first motion type is raised. The first motion type is any object. Okay, for easy understand, think about vehicle. How many motion types? Okay, what do you think? Think there is a vehicle on this road. This is a road. This is a vehicle. Like a bus. Then how many motion types for this bus? What do you think? How many motion types? The one is, think now the bus stand. Now it is rest. The rest is one motion type. Rest. That means the object is not moving. It is static, not moving. Okay, what are the other motion type? Then the bus is starting and try to move. Then what happened? The bus speed gradually increasing. What is the call that? With time, bus speed is gradually increasing. Very good. With time, bus speed is gradually increasing. What's the name? Very good, Setmal. I think correct. What's the name? Very good. Others? I asked. Yeah, first motion type is clear, no? The static. Static means the rest. The object is not moving. The second motion type is bus start to increase the bus put into first gear, then accelerate. That's the word. No? Acceleration. With the acceleration means with time the speed is increasing. Increase the speed with time. We discussed later. Don't worry. Now understand. The second motion type of any object is acceleration. I will write it as a third one for you better understand. Acceleration. Okay, after that, think this bus is enter to the highway, expressway. Then what happened? The bus is moving, bus is traveling with same speed. What's the call that? What's this motion type? Normally, you know. Very good, Tinul. The bus is moving with which? Very good, Yumet. No serving. Very good. Uniform, Fatima. Uniform motion is not the accurate. Yeah, uniform velocity. That's it. Uniform velocity. Uniform velocity. Okay, uniform velocity. Okay, now the bus going to start. Bus at the exit of the highway, as example, at the exit of the highway, bus going to stop. Then gradually with time, speed, what happened? Decreasing. Then what's the name? What's the name? With time, bus speed is decreasing. What's the name? Very good. The name is deceleration. 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 Okay. Up to now, in the linear motion is like a vehicle is moving. Vehicle is moving. They are the main motion type. It can be rest. It can be uniform velocity. It can be accelerate or decelerate. Okay, they are the main motion type we discussed in the linear motion. But when we consider about rotational motion, we have different motion type that we discussed in the next lesson. Okay, the force and rotational motion, if it is 2 lesson in our syllabus, it just like the first part and second part of the first lesson. In the first lesson, we mainly discussed about the linear motions, little bit about rotational motion. In the rotational and circular motion, we going to discuss further about rotational and circular motion. Okay, now don't think about rotational motion, only come to this level, this lesson. When we consider about any linear motion object mean, I think you can understand, like a vehicle, like a object is, like a box is moving like this, like box is moving in a horizontal vertical way. They are linear motion, like a line motion, like a line, not rotation. Rotational motion we discuss later. Okay, in the linear motion, they are the main motion type we discuss. That can be rest, that can be uniform velocity, that can be accelerate or decelerate. Okay, what is the meaning of force? Still we discussing about force. What's the meaning of force? That's an external agent which can change the motion type of any object. That can change the motion type. This external agent can rest object convert into uniform velocity object. Uniform velocity object convert into accelerate object. Accelerate object convert into rest object. Accelerate object convert into deceleration object. Accelerate object convert into uniform velocity object. Whatever, change the motion type from one motion type to, think it's initially it's uniform velocity, then convert into acceleration. What, from any motion type to another motion type, it can be convert, that we called as the force. Then how we explain the, don't remember only this word, you should have a proper knowledge about the meaning of these words. Okay, then how we identify the force? The force is an external agent which can change the motion type of any object. In the tute also I have given the definition. No? The problem is at least me also don't have now tute, printed tute. Your printed tutes again come tomorrow. Then I have to use a soft copy. Yeah, the tute. Okay, I have given a force is an external agent that change the motion of any object or induce it to change the motion. Okay, that's the full definition of the force. That is, applying a force can move stationary object, bring a stationary object to rest, or change the velocity of a uniform velocity object. Uniform velocity object change the velocity. Change the velocity mean it convert into deceleration or acceleration. That's the meaning of the force. I got the full, only I explained about first two sentences. I got. I got the first two sentences. Only what's the meaning of force? Only force. What's the meaning of force? There, I got. Force එකක් කියලා කියන්නේ an external agent එකක්. එයාට පුළුවන් වෙන්න ඕනේ what motion එක change කරන්න, motion type එක change කරන්න. හරි නේද? Yes or no? Send me quickly. I got the basic. What's the meaning of force? Only I explain. Good, good. Okay, very good. Very good. Whatever motion can be changed, any external agent. Okay, that's the meaning of force. That's the meaning of force. That's the meaning of force. Okay, now third point of the dude. If anything you want to note down, you can write. I'm not going to give the full notes, writing notes for this force lesson. For other maths lessons, I always giving writing notes, but this lesson I not given especially for note. You, if there are any point, if I explain in the board, you can note down if you know, if you need. Okay, if you need, you have to decide. This motion type I not given in the tune, but you have to note down. Okay, when an external force is applied to, third point, when an external force is applied to an object, the questions that naturally arise is in which direction. That is, the applied force has not any magnitude but also direction. Such quantities are called as third point is sorry, I have mistake with word. When an external force is applied to any object, the question that naturally arise, what is the direction of that? Yeah, what is the direction of that? That is, the applied force has not only a magnitude. Yeah, when we consider about force, the third point, when we consider, I got complete this one. Can I erase? Can I erase? Okay, I have given everything. You can, if you want main motion type in linear motion, you can note down. Main motion type in linear motion, you can note down. Other things don't need, no? Okay, now the third point is, when we consider about this external force, when we consider about this external force, before we go to the external force, quantities, physical quantities, as we discussed in the measurement lesson, physical quantities, mainly we can measure scales and vectors, no? Physical quantities, physical quantities, physical quantities, physical quantities, physical quantities, physical quantities, mainly we can divide scales and vectors. Do you remember what's the meaning of scales and what's the meaning of vector in O level? That's simple things. Sorry, vectors. Do you remember what's the meaning of vector and what's the meaning of vector and what's the meaning of scales? Do you remember what's the meaning of vector and what's the meaning of scales? What's the meaning of vector? What's the meaning of vector? Before we go, scales, vector, very good. Very good. A force that have both, no, not force. I asked just vector. Setmal. Don't think about force. Yeah, scale is quantity which having only magnitude. Very good. Very good. Abhi. Vector physical quantity with very good, very good. You all are correct. I think others also you already know in O level time. Vectors mean physical quantity with with magnitude plus direction. Magnitude plus direction. Okay, scale mean physical quantities with only magnitude. Very good. Only magnitude, no direction. Only magnitude, no direction, no specific direction. Only magnitude. Sorry, magnitude. Only magnitude. Okay. Can you give me examples for scales first? Few examples for scales. Few examples for scales. Yes. Very good. The mass, time, other example. Speed, very good. Speed, very good. Speed. Okay, that enough. Okay, they are the and distance, no? Yeah, what others? Yeah, distance, very good. Distance, they are the physical quantity with only magnitude. They we called as scales. Okay, then tell me example for vectors. Examples for vectors. Yeah, you can refresh your O level knowledge. Vectors, very good. The distance is the scales, but the displacement is a vector, no? Do you remember? Displacement in O level, displacement, velocity, everything, velocity, yeah, acceleration, very good, acceleration, deceleration, also every quantities with magnitude plus direction. Yeah, lot of answers. I can't write all. Yeah, very good. Lot of answers. Displacement, acceleration, weight, velocity, force. Your lot of answers you have include weight and force both. Is it difference? Is it different? Is it difference? Weight and force? Actually, within 5 to 10 minutes, you will solve this problem. Actually, weight, if it is weight is a vector, force automatically vector. If it is force vector, the weight also vector. Okay, you can solve this problem within 5 to 10 minutes. Keep attention. Okay, as I told earlier, that lesson is not like measurement, very interesting. I will do my best to explain everything in very simple way. I do, because that lesson is this much important. Okay. Yeah, what answers? Yeah, you have I have a lot of answers, everything I can. Yeah, all are same answer, therefore I stopping reading them. All are same answer. Then you want to remember the force also a example for vector. That only you need to remember. The force also a example for vector. The force also a example for vector. Every force type. Okay, force mean every force type. In future parts we discuss the friction force, the different friction force, resultant force, moment of force, for equilibrium force, every forces. Then what? A vector. Every force is a vector. What's the meaning? Then the force is a vector. It has magnitude plus direction. The force is a vector. It has magnitude plus direction. There is a connect me. The power is a error. Therefore, the power is a vector. It should be force. Therefore, the force is a vector. In the tute, page number 1. Therefore, the force is a vector. Mistake. Therefore, the force is a vector. Force is a vector. The force is a vector. Your tute should be correct like this. Okay, that's you want to understand. That you want to understand. So in second point, bring a moving object to rest. Right. Yeah. That is applying a force can move stationary object. Yeah. More stationary object, that correct. More stationary object. Stationary object, more. Stationary object to rest. This wrong, no? The moving object to rest. Moving object to rest. Or change the velocity of a uniform motion. Yeah, that's correct. Yeah. In the second point, the stationary object to rest should be correct into moving object to rest. Moving object to rest. It has mistakes. No? I think only first page. Second page. Yeah. From second page, no mistake. Actually, I couldn't check the basic part. I couldn't check because they are very simple parts. But final part I have checked before printed. The second point, it should be correct. It should be correct. Applying a force can more a stationary object, comma, bring a moving object to rest. Moving object to rest, not stationary object to rest. Stationary and rest both same. Okay, correct that. Okay, that's the first paragraph. Are you good? That's the explanation of first paragraph. You okay? Finally, what you need to understand on this first basic things. What you need to understand: the force is an external agent which can change the motion type of any object. No, the force is an external. The force is an external agent which can change the motion type of any object. And as example, rest object convert into moving object, accelerating object, whatever motion type change. Okay, and the force has the direction and magnitude both. Therefore, force is a vector. Therefore, every force type has magnitude as well as it has direction. Are you good? Up to now? Up to now, only 3 points we discussed. Only 3 points. Now, we are in the very basic level. Only 3 points we discussed. Are you good? Better to prepare your own short note. Okay? Better to prepare every, not the physics lesson, not compulsory, but this lesson also theory part you can try. In our 25 students, they prepare every lessons, they prepare short notes. Short notes. You can start now. Short notes. Short notes mean you can take few writing papers. You can take few writing papers and you can this every important things I explaining in the lesson, you can get into this paper, and finally you can attach your writing papers into a I given tube. At the final part you can attach these papers, then you have full and note full note, printed notes, and important things I explain in the class. You have write down, and you have attached in the at the end of the tubes. Then when you after 3 to 6 months, think after 1 year, that's little bit long time. After 12 months, 13 months, 14 months, if you got the first lesson, you have everything to learn. You have everything to learn. Then you don't need to again watch recording, don't need. Then you can manage your time easily at the final days of the exam. You know, these final months, when you think you have only 4 months to the exam, 4 months to the exam, you have only 4 months, 4 level. Now I am explaining 2024 students situation. Now they have an 4 months more, 4 months left for the exam. Okay, therefore they can't do again watch recording. They can't whatever go through one by lesson at the beginning. They can't do this, because this lesson, after we discuss this each and every lesson, we need to discuss for further advanced questions. Otherwise you can't go for the exam. If you know first lesson every theory parts, every calculation, you can't go for the exam, because you have to practice these questions in more than we in our revision program. We doing more than 100 papers, more than 100 full papers. If you want, you can watch our few revision videos I have uploaded into youtube. You can watch. Normally our class is 2025 class is going more than 6 hours, then this 2 days they have class only for SFT. Monday, nowadays Monday 6 to 11 p.m. and Tuesday 6 to 11 p.m. they have class only for SFT. And final 3 months they have another 3 hours add to this. Then for 1 week we working 6, 12, 15 hours only for class. They have to work as individually. They can work more than that. Therefore we doing work, otherwise we can't get result. We have to do work hard, very, very hard. I just want to explain better to prepare notes for each lesson. Each and every lesson, prepare notes in handwritten notes, your own notes. That will very important for your future studies. If you have printed any notes, they are not your notes. They are given in another whatever ideas. Then you have to understand these things, and if you can write this understanding points in your words, your letters, that's more important for your future studies. Okay, try this. Especially if you're doing A level 1 year, as example Fatima, Kabir, who are there? If you're doing it 1 year, you have to compulsory practice this one. Every lessons you have to prepare short note. Okay, if you don't if you can't understand how to prepare short note, send me WhatsApp into previous number. Okay, I will explain. Okay, now the force. Okay, now I told the force is a vector. No, the force is a vector. Vector mean what? It has magnitude as well as it has direction. magnitude and as well as it has direction. Now the force. When we expressing any force, normally we use arrow like this. If I expressing any force, normally I use arrow like this. Arrow like this. Expressing any force, normally I use arrow like this. Arrow. Now think I want to express 50 Newton external force, external agent. I want to explain in anywhere. Then I can say in this force explanation, 1 centimeter equal to 10 Newton. 1 centimeter equal to 5 Newton. 1 centimeter equal to 5 Newton. Now I can express this force by this arrow mark. Remember, the length of the arrow always explaining the magnitude of the force. Magnitude of the force always explain the magnitude of the force. The arrow mark always explaining the direction of the force. Understand, focus well. Direction of the force. Okay, now any force we can express by an arrow mark by the direction and magnitude, both we can express by an arrow mark. Remember, now direction is easy, direction is whatever the arrow mark direction is, the force direction. Now how we express magnitude by the arrow? Magnitude how we express by an arrow? Remember that we express by according to a scale. We express the magnitude. Remember, think 50 Newton I want to express. Understand now. 50 Newton I want to express. Now I select any suitable scale. 1 centimeter of the arrow equal to 5 Newton. Then to express the 50 Newton, my length of this arrow, should be, what is the distance? What's the length? It is 10 centimeter, no? 10 centimeter, because 1 centimeter express 5 Newton. Then 10 centimeter express 50 Newton. I got? Yes or no? I got 1 centimeter express 5 Newton. That's not the fixed scale. The fixed scale is according to our requirement. The scale is according to our requirement. If I got 1 centimeter equal to 10 Newton, then my arrow length should be 5 centimeter, no? Arrow length should be 5 centimeter, no? Therefore, now the scale is 1 centimeter equal 5 Newton, then my length of the arrow should be 10 centimeter. This is the force direction. I got? Very good. Very good, all liars. Very good. Very good. Okay. Okay, I have given here. Uh, okay, topic 5.1, the nature of the force and its effects. There are three factors necessary to full describe the force: the magnitude of the force, the direction of the force, the point of application of the force. The point of application of the force we can understand in the movement of forces. That don't think about that. uh, the standard international unit that we explain later. A simple line draw to scale can present a force in a diagram. In the I'm reading the tute. In the context, if a 1 centimeter equal to 15 newton, now the scale is different. You can see 1 centimeter equal to 15 newton. A line 6 centimeter long should be drawn to represent. No, it also the range given in the tute 1 centimeter equal to 5 centimeter. Correct that. 1 centimeter equal to 5 centimeter. Sorry, 1 centimeter equal to 5 newton. Then 6 centimeter long should be drawn to represent 30 newton force. 6 centimeter arrow, 6 centimeter arrow, it is represent 30 newton force. 6 centimeter, 30 newton force. 6 centimeter, 30 newton force. Here magnitude of the force is represented by the xy. That means xy is this, xy, the length. Xy is the length. That is the magnitude. Okay, that means that it is 10 centimeter, then 1 centimeter equal 5 newton, it is 50 newton. Like this. According to the scale, we can calculate the value. The direction in which of the force acts is represented by the arrowhead at y. Arrowhead. I think you don't need to explain more. Point x is the point point x is the point of application of the force. Okay, that we can understand in the, that's the point x. This one is the point, acting point of the force, application point of the force, that we can just later understand. Then remember, this is the force application, acting point of the force, or application point of the force. Acting point of the force, acting point of the force, acting point of force. Okay, that's the full summary. I got the second summary. First we discussed what is the meaning of force, then we discussed the force is a vector, then we discussed how to express a force. How to express force by line and arrowhead. Length of the arrow express the magnitude, the arrowhead explain the direction, the starting point of the arrow explain the acting point of the force. Starting point is explained the acting point of the force. Okay, this one we can discuss further in movement of forces. Okay, this one now still you can't understand the 100% idea of the acting point. When we discussed more parts, you can understand what's the meaning of acting point. Okay. Okay, do you know what is the SI unit of the new that answer Q9? What's the standard SI unit of the force? SI unit of the force? SI unit of the force? Very good. Do you know who is the Newton? Yeah, Newton is the SI unit. The capital N is the SI unit. Do you know who is the Newton? How the Newton क्या? Do you know, if you don't know Newton, do you know Isaac Newton? Isaac Newton දන්නව නේද? Father of the modern physics. Yeah. Which character, which type of force they have introduced? He has introduced what is the famous the law, the apple story. Yeah, the gravitational force, no, the gravitational force of the earth found, actually it not found, it already available thing that, but this theory explained by the Isaac Newton. Not only gravitational force in O level and in childhood time you only know the Isaac Newton only found uh, the gravitational force of the earth. Not only that, the Isaac Newton is the scientist of the, yeah, you made correct, the father of modern physics. That means the Isaac Newton is the scientist has explained lot of forces related theories in the not lot of many theories in the forces related explained by the Isaac Newton. That's why actually the force unit is not Newton. Actual unit is Newton, never, not Newton. The actual unit of the force is actually kg ms minus 2. This is the actual unit of the force. kg ms minus 2 is the unit. But for respect for the scientist, this 1 kg ms minus 2 normally we identify as 1 Newton. We can discuss in the calculation parts. We can identify the actual unit is kg ms minus 2. kg ms minus 2 is the actual unit. But for respect for the scientists who found these theories, for respect, we consider 1 kg ms minus 2 is equal to 1 Newton. 1 Newton. 1 kg ms minus 2 equal to 1 Newton for respect for the Isaac Newton. For Isaac Newton. Do you know how many Newton's laws? How many Newton laws? How many laws has introduced by the Newton? How many laws? How many laws? Now we going to discuss about Newton laws. Newton's law. Newton's law. That's our today lesson. Actually, today lesson only we discussed about Newton's law. Now we come to the actual, up to now we discussed in the summary. In the summary, we completed this part now completed. The basic of forces, that done. Then we go into our second part, the Newton's law. Newton's law. Newton's law. Newton's law. Okay, you all are correct. We have discussed about three Newton's laws. Yeah. We have discussed about three Newton's law. Newton's law. We have discussed about three Newton's law. Okay. Do you remember what he explained in the first law? What he explained in the first law, first one. In the first law, what he explained? What he explained in the law number 1. Okay, think think and try to refresh your O-level knowledge, I can give you, do you need, normally our class will continue up to 9 today. Do you need 3-minute break before go to this part? Because if we start this part again, we have to continue up to end. Okay, get again join 8:20. Don't anyone left, and drink some water and come again. Okay, I came. Are you there? Now time enough now. Have you drink water? Okay. There is a good question. Who is asking? You met, no? Sir, so weight is also kgms minus 2. Does that mean it's equal to force? Yeah. The you made the force, the weight also or type of force. It's not a specific physical quantity. The weight also of think this is an object. Actually, in this part we discuss this. Actually, I will explain for your question. The weight is the force into gravity direction always. The weight is, if it is 5 kilogram object, the 5 kilogram object, the weight equal mg, the mass into gravitational acceleration. I think all over time you know. Then the mass into gravitational acceleration, then 5 kilogram into gravitational acceleration in same as O level, the gravitational acceleration we consider as 10 ms minus 2. 10 ms minus 2, then you can see 5 kg ms minus 2 is the answer. 5 kg ms minus 2 is the answer. Then the weight we called as 5 Newton for respect for the Newton. Understood, you mate? Actually, in this, after we discuss Newton's law, you can get full idea for these questions, full solution for these questions. Okay, yeah, you all are correct. The Newton's first law is until unbalanced force is acting, until unbalanced force is acting, mean actually now what is acting in this time? Until unbalanced force is acting. That means if there are no any unbalanced force actually this, as I told about this Newton's law, you can get 100% idea at the end of the lesson. I will explain again, come to the Newton's law and I will explain. But now understand what is the basic idea of Newton's law. The first law is if there are no any unbalanced force act on any object. If there are no any unbalanced force, mean it's like this. 5 Newton into this direction, 5 Newton into this direction. 5 Newton into this direction, 5 Newton into this direction. Is there any unbalanced force? No, it is balanced, no? 5 to 5 balance. 5 to 5 balance. In this case, in this object, unbalanced force, if there are no any unbalanced force act on any object, think this object is now raised. Now this object is raised. Rest objects are no any difference rest. Rest objects are rest, and moving objects, if think because of any reason this object is now moving. The object is moving. It's moving with uniform velocity. Uniform velocity. Uniform velocity. Uniform velocity. Uniform velocity. That's the meaning of the Newton's first law. Newton's first law. How we explain that? If there are no any unbalanced force act on any object, if there are no any unbalanced force act on any object, or until any unbalanced force is acting, until any unbalanced force acting mean in this time no any unbalanced force. If there are no any unbalanced force act on any object, rest objects are rest and moving objects are moving with uniform velocity. Rest objects are rest. Rest objects are rest. Moving objects are moving with uniform velocity. Moving with uniform velocity. That is very easy to understand Newton's law. If as I explained earlier, I told when we consider about any linear motion object, it has only 4 motion types, no? It has only 4 motion types. The first one is object can be raised. Object can be raised. The second one is uniform velocity. Uniform velocity. The third one is acceleration. Acceleration. The fourth one is deceleration. 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 Then on this, as I told in linear motion, there are 4 motion types. From this motion type, the mainly in the first law in the Newton, in the first law, they have explained about the rest object and uniform velocity object, no? In the first Newton's law, he has explained about the rest object and uniform velocity object. That means we can say if any object is rest or moving with uniform velocity, no any unbalanced force. Are you good? Are you good or need to explain again? Yeah, very important point I explained. Very important point. What is the Newton's first law we called? If there are no any unbalanced force, rest objects rest and moving objects moving with uniform velocity. Then if I consider rest or uniform velocity objects, then can we decide no any unbalanced force? No? Are you got? Then if I write rest object or moving object, no any unbalanced force? Correct? No any unbalanced force. Are you good? Focus very well. They are the points you need to understand. They are the point you need to understand. Fatima, are you good? The Newton's first law is if there are no any unbalanced force act on any object, moving objects are moving with uniform velocity and rest objects are rest. Then if any object rest or uniform velocity, then we can decide this object is balanced. No any unbalanced force. Fatima, you got? Okay, any doubt? Quickly ask. If you have any doubt, quickly ask. Now we're going to discuss about little bit in depth of force. In depth of force lesson, we actually this point we start. Okay, that's a Newton first law. Newton first law. Newton first law. Newton first law. Okay, then I will. In doubt? Can you explain again? Very good. Okay, understand. I got the Newton first law, Uta. I got the Newton first law. The meaning, the Newton first law mean if there are no any unbalanced force, that means the object is balanced. No any unbalanced force is balanced. No? If it is balanced, no any unbalanced force, rest objects are rest and moving objects are moving with uniform velocity. Okay, moving objects are moving with uniform velocity. Rest object rest, moving objects moving with uniform velocity. Think then I have rest object. Then think that's a rest object. The object is rest. Object is rest. Object is rest, not moving. Then I can decide this object is balanced or unbalanced object. That is a balanced object. Why? The object is rest. I got. Then I think the vehicle in the highway vehicle is moving with 100 kilometers per hour without any change. Without any change, uniform velocity. Then I can decide at that time the vehicle is balanced. No any unbalanced force. That's why the object is moving with uniform velocity. Sarmiane. Are you clear? Okay. Okay, actually, if you can't understand any point still, don't worry. If you can ask, but as I told 100% what I explaining here, what's the actual meaning of this part? Meanings you can get at the mid or end of the lesson. You can get the full idea, but if you can't understand any point, don't miss these parts. You can ask. Then if you can't understand, you can find anywhere internet, or if you not, you can continue the lesson. Any part you can't miss. If you continue this, it will at the end of the lesson you will clear as a clear picture, clear story. They will very easy for you. Okay, then come to the second law of Newton's second law. Newton's second law. Newton's second. That's the first law. That's very easy. The Newton's second law. The second law is the most important law. To explain the Newton's second law, we have two methods. We have two main methods to explain the Newton's second law. Okay. Okay. Before we understand the second method, first we'll identify the common methods for Newton's second law. Common methods. Actually, as I explained, understand this part very well. If there are no any unbalanced force acting, the object is rest or uniform velocity. That's the first law. If there are no any unbalanced force is acting, the object is rest or uniform velocity. Now think, if I change this value into 3 Newton, now is this object is balanced or not? The object is balanced or not? If you want, I'll draw it again. Now this is the object. This one 5 Newton. This one 3 Newton. Now this is a balanced object or unbalanced object? That's a balanced object or unbalanced object? Yes, it is unbalanced object because it is unbalanced object. Very good. It is imbalance, no balance. If there are any object, if there are any object not balanced, that's the second law. Very simply you can understand. If there are any object balance, this tell me this one, what is the motion type of this object? Now this object is not balanced. Don't they get more complex? What is the motion type of this object? Is it possible to rest? Is it possible to stationary? Rest තියෙන්න පුළුවන්ද? No. Is it possible to moving with uniform velocity? Uniform velocity එකෙන් යන්න පුළුවන්ද? Bad. No, can't. Remember, always if there any object is unbalanced, it is accelerating or decelerating. Remember, it is accelerating or decelerating. If there any object is not balanced, it is accelerating or decelerating. Okay, now I think you can remember, if there are any object rest or uniform velocity, it is always balanced. If there are any object accelerate or decelerate, it is always unbalanced. Remember, it is always unbalanced. Remember the first 2 points, rest and uniform velocity, relevant to the first law of Newton's first law. The acceleration and deceleration relevant to the Newton's second law. Then if there are any unbalanced force, then tell me again, what is the first law? Summary. Get very simply. If there are no any, go to the first law. If there are no any unbalanced force, I will change again into 5, because if there are no any unbalanced force, if there are no any unbalanced force act on any object, rest objects are rest and moving objects are moving with uniform velocity. That's the Newton's first law. What's the second law? Very simply understand. Very simply you can remember. If there are unbalanced force are acting on any object, the object is accelerating. Acceleration minus value is the deceleration. I think you remember in the O-level time. The object is acceleration. If it is acceleration value is minus, it is the deceleration. Then we can commonly, if there are unbalanced force on any object, the object is accelerating. I got, if they are unbalanced force, that you need to understand. That's the point. Remember, if there are no any unbalanced force, the object is rest or uniform velocity. If there are any unbalanced force, if there are any unbalanced force, the object is exactly acceleration. Acceleration. That's the summary you need to remember. Acceleration. The object is exactly accelerate. Are you good? If there are no any unbalanced force, this is the first law. It is rest to uniform velocity. If there are any unbalanced force acting like this, if there are any unbalanced force acting, it is exactly accelerating. Are you good? Are you good? Are you good? Are you good? Yes. Sarmia, are you good? Are you got these 2 points? Very good. Okay, if there are no any unbalanced force, it is rest or uniform velocity. If there are any unbalanced force, it is exactly acceleration or deceleration. The deceleration also minus acceleration. Therefore, we can commonly say it is accelerating. Accelerate. Now, that's not the actually Newton's second law. Newton's second law is, if there are unbalanced force acting on any object, it is exactly accelerating. Unbalanced force acting, it is exactly accelerating. Then this acceleration, understand, this acceleration mean simple A, acceleration directly proportional to the external force. Directly proportional to the external unbalanced force. This part is the most important one. This acceleration directly proportional to the, this is the proportional mark. Okay, this is the proportional mark. This is the proportional mark. Then this is the acceleration. Acceleration directly proportional to the external unbalanced force. External unbalanced force. Okay, that's the first thing. That's the first thing. That's the first thing. And this acceleration, this acceleration inversely proportional to the, inversely proportional to the mass of this object. Understand the mass of this object. Mass of this object. This is my second point. Sorry, inversely proportional to, inversely proportional mean not m. You will understand when we discuss 1 over m. Okay, this is the acceleration directly proportional. This is a proportional mark. Proportional to the f. That's directly proportional. We write like this. The acceleration inversely proportional to the, that is a directly proportional. Directly proportional. Don't get complex, very simple. Directly proportional. Directly proportional. Directly proportional. Directly proportional. This one is inversely proportional. Inversely proportional. Inversely proportional. Directly proportional and inversely proportional. Directly proportional mean actually, the directly proportional mean understand when increase the external force, understand when increase the external force, external unbalanced force, acceleration also increasing. When increase the, yeah, Sitman. This is the proportional mark, no? Both one proportional. The with F external unbalanced force, it is proportional directly. That's why A proportional to F. But A proportional to inversely proportional means A proportional to 1 over F. That's the meaning of inversely proportional. Sitmal, are you good? Okay. Then you want to understand the acceleration directly proportional to the external force mean, external unbalanced force mean, when increase the unbalanced force, the acceleration value also increase. Acceleration එකත් වැඩි වෙනවා, දෙකම වැඩි. මේක වැඩි වෙද්දි මේකත් වැඩි වෙනවා. මේක වැඩි වෙද්දි මේකත්. Like the F increase, the acceleration increase. Like this. The inversely proportional mean when increase the mass of this object, the acceleration become decrease. That's the difference. Inversely proportional mean the proportional mark same, but it is 1 over F. When the mass increase, the acceleration go down. Mass increase, go down, like this. Okay, that's the meaning of directly proportional and inversely proportional. Directly proportional and indirectly, that also inversely proportional is the perfect one. Okay, then how we explain the Newton's second law? I have given in the tute. Newton's second law කොහොමද කියන්නේ? Yeah, heavy rain, lot of side, no? Yeah, lot of send me message, they have rain. Okay, no issue. I'll you can again watch this Saturday, this same class you can again watch Saturday. I forgot to tell you, no? From this week, this fourth lesson, you can again watch this same class Saturday, same time, 6:45. 6:45. You can. I'll schedule in the YouTube, and if you want, you can again watch this today class Saturday 6:45, same time, 6:45 to 9. Saturday, if you want, if you have any doubt to join with today with your another class or whatever class, you can again, if there are any more clarification about our class, you can again join Saturday 6:45 to Sunday evening, Sunday 7 p.m. Anytime you can watch this. Anytime you can watch. I will give you a link for into the group. Anytime, if you want, you can watch this same class that's going as a streaming. From next month, we are developing a new website for you for our online class. Actually, not for you, our 2025 and 26 students, but you also, I hope to you also register in the website. Then if you want, it has lot of options. If you want any part miss, you can watch again through the website. No need to request link or no need anything. Everything in the every papers, our everything in the class you can find in the you can search internet in my name, then you can go to the website, and if after you register with your ID number and your email, then you can access all. If you want, you can pay class fees with your bank card, ATM, debit or credit card. You can pay class fees, then automatically you can open your course page automatically. Then if you want, you can, as same method, if you you can, if you want, you need to pay into bank payment, you can pay class fees and send me receipt, then I can give you access in the each month of the website. From next month it will be, it we can start that. I think July 5th we have given access for the, they will give us access for the website next month, not this month. Okay, therefore now we are doing little bit advancement of our class. Now you are in the golden time of our class. Now we are doing lot of investment. The opportunities of our investment, you can get opportunities of that. Therefore, get the maximum benefit of them. Don't miss any part. That's why my main advice is, don't miss any part of these lessons. Okay, as I discussed. Okay, now how we explain the Newton's second law? Newton's second law. Okay, I have given in the tute. Go to the tute. Momentum important for second part. I will explain later. Newton's second law, law of acceleration. Law of acceleration. The acceleration of an object is directly proportional to the net force acting on object and inversely proportional to the mass. Are you good? The direction of the acceleration is the same as the direction of the net force. Yeah, that's correct. The net force mean this. The net force, you can understand the, can you write down near net force within bracket, net force within bracket, still you can't understand what's the meaning of net force? Can you write down in the within bracket, it is unbalanced force. Unbalanced force. Actually unbalanced force, but after that, after we discuss resultant force, we can call it is resultant force or net force. That's okay. Now, according to our knowledge, can you write down within bracket, it is unbalanced force. Unbalanced force. Unbalanced force. Okay, now read the Newton's second law. Newton's second law. The acceleration of an object is directly proportional to the unbalanced force acting on it and inversely proportional to its mass. Okay. The direction of the acceleration is the same as the direction of the net force, mean direction of the unbalanced force. Direction of the unbalanced force. Unbalanced force. Okay. Up to now, that level is enough. Unbalanced force. Okay. I got how to explain the Newton's second law. The Newton's second law is, now you can understand the Newton's second law, how we explain. Simple, eh? Simple. Now summarize our two theory. Now summarize. If the Newton's first law is, if there are no any unbalanced force, only focus into that. The Newton's first law is, if there are no any unbalanced force, rest objects are rest and moving objects are moving with uniform velocity. That's the first law. In the second law, I told, if there are any unbalanced force acting, on any object, the object is accelerating. This acceleration is directly proportional to the unbalanced force and acceleration inversely proportional to the mass of the object. Can you write this? Can you understand? Any doubt you can ask? Any doubt? Any doubt? Or yes or no? Are you got the difference between first law and second law? Then if anyone asks, can you explain what's the difference? If anyone asks, what is the difference between Newton's first law and second law? Can you explain? Yes or no? Yes. Others, are you okay? Send me all yes or no. Otherwise, I don't know if you have any doubt. It's a problem here. Okay. Quickly. Yes or no? If you couldn't get, send me, explain again. Okay. Okay. Okay, now according to Newton's second law, now the final point, according to Newton's second law, the acceleration directly proportional to the external force and acceleration inversely proportional to the mass of the object. The directly proportional mean external force increase, the acceleration auto increase. The inversely proportional mean the mass increase, the acceleration is decreasing. That's the meaning. Okay. Now we can get this. The both acceleration a is same for same object. Therefore, I can write the acceleration directly proportional to the, focus very well, acceleration directly proportional to the f into 1 over m. F into 1 over m. Acceleration directly proportional to the f into 1 over m, because this both a is the same value. Okay, that don't need to get maximum 100% these steps. Then directly proportional to the f into 1, it is f over m. F into 1 over m. F over m. Now f over m. Now with with this proportional mark, we can't do calculations. With this proportional mark, we can't do calculation. Therefore, I'm going to remove this proportional mark. If I remove in physics, if I convert the proportional mark into equal mark, I have to put a constant. Yeah, that's I'm doing. I have to put a constant. Remember. Therefore, I use the constant is k. K is the constant. F over m is the, now that's the equation. Now the Newton is Newton has found the k value is, the k constant value is 1. The k value is 1. Therefore, the k value is 1, then we can say if a equal f over m, the 1 will multiply kara kala mukut wenne, and then 1 into f over m, it is f over m. Then we can say the cross multiplication f equal m a equation we can get as final equation. Then we can do in next week we can do more calculation using this F equal ma equation. F equal ma equation. Understood? That's why F equal ma, the common equation of the Newton's second law is coming. Newton's second law common equation F equal ma is coming because of this calculation. Okay, I have given in the page number 3 in the TUT page number 3, TUT page number 3, sorry, page number 5, TUT page number 5, actually page number 3, I think, yeah, page number not correct, no? Page number has calculated with the cover page, no? With cover page, page number 5, I have given the space for F equal ma, and page number 5 I have given space. Then given space, please draw this diagram. Please draw this diagram. Then write down this one. Write down this part, and as final get the F equal ma equation. F equal ma equation. Any doubt you can ask. That is the actual. Now we go into the force calculations part. That's the first equation we met in the force lesson. That's the first equation, F equal ma. That's the Newton's second law. If there are any equation in Newton's first law, no, Newton's first law, no equation. Newton's first law, you want to understand if there are any any unbalanced force, it is restore uniform velocity. I think you go. This one don't need, okay. This one don't need. Only diagram and this part. If you want, you can note down this summary in a corner of the TUT. Complete? Complete writing? Complete? Okay, that's our today target. Then I got from the Newton's first law, Newton's second law, F equal ma equation I got. F equal ma equation I got. I got equation F equal ma. F equal ma is my equation. Okay. Can we get more 3 minutes? Okay. 9:05 I will finish. Okay, then F equal ma, it is our first equation of the force lesson we met. Okay, now what is the name of this F? What is this F? What is the F? Quickly, what is the F? All are wrong. 4 answers, all are wrong. Fatima, what do you think? What's the F? What's the F? F equal ma equation. What is the F? Very good, Setma. Only one answer correct. I think 6 answers. From 6 answers, only one correct. The F equal, always remember, F is not force. F is not force. F is always unbalanced force. Unbalanced force. Unbalanced force. Unbalanced force. That's very important. In your final equation, you can name the F is unbalanced force. Within bracket you can write it is resultant force. Resultant force. Don't think about these names. I will discuss later what is the meaning of unbalanced, what is the meaning of resultant. That's same. That's both same. Unbalanced force, within bracket, this F is not force. It is resultant force or unbalanced force. The M is the name of M. What is the name of M? M. Very good. The mass of the object. Mass of the object. That don't. A mean acceleration of the object. Acceleration of the object. Okay. That's we need to discuss today. That's our target we have achieved. From next week we going to discuss about further, and we need to discuss about next week. We have to start from the momentum. We're going to start the Newton's second law. We can discuss in another form that we using momentum next week. Can you find the meaning of momentum next week? That's a homework. Okay, the momentum. What is the meaning of momentum? I not have given in the tune. Momentum meaning of I don't need the equation. The equation I can give you. The momentum equal capital M equal mv. No? I need what is the meaning of the momentum. I need what is the meaning of the momentum. You can try. Yeah, P O capital M, no issue. Sigma. That we called the P also, capital P also, no issue. P equal MV issue, no issue. I need you can find anyway, whatever Chat GPT or Google or whatever, you can find what is the meaning of the momentum. Then we can start the second part of the Newton's second law. Then you have to practice. Today we discussed up to now. Then the second part will be very easy. Okay, then next day, within very short time, very small time, we can complete the Newton's law, and we can go for friction force, our third part. Okay, where are we discussing now? That's our summary. Okay, some part of this half we discussed on the Newton's law. Then we have few topics, no? Simple, not too difficult, but if you miss any part, it will be very difficult. Okay. Any doubt from today? Listen. Okay, then we'll meet next Thursday. No any date different. If you want, you can watch the same class Saturday same time. Okay, Saturday same time. After we finalize the website, you can watch the anytime you can watch classes after we launch the website. Okay, then goodbye. Good night.